Welcome, everybody. Thanks for coming to the PostgreSQL Extension Ecosystem Mini Summit #4. Today, I'm pleased to have Jonathan Katz from AWS come and talk to us about trusted language extensions, the vision and the specifics there, as he framed it. And I'm looking forward to learn more about that. So, Jonathan, I'll turn it over to you.
Thank you, David. So let me now see how long it takes to share the slides.
Hey, look at that.
Look, nice and easy. Okay. Let me make sure I can see everything. I don't have my two monitors with me, so this will be fun. So, thank you for having me. I'm very excited to talk about this. Definitely excited to talk about extensions in general. So, I do see that there's a lot of folks here I know and recognize, and some new folks, or if new folks that perhaps we've not met in person yet, because I recognize a lot of the names. So the way I want to set this up is I actually borrowed from the original presentation on trusted language extensions when we announced it in November of 2022, in part to just level set in terms of of why we built it. And I've noticed that this is a slightly more advanced audience. I know there's folks from all over the board. So there's some stuff that might seem like relatively introductory to some folks where, on the flip side, it's actually what we'd call the 400 level content, where we look at some of more of the internals of the extensions. But really, I think the premise is why did we decide to build trusted language extensions? What are the problems that we're trying to solve here? And part of it is just understanding Postgres extensions. And again, I think going into the first slide, if of course I forgot my slide clicker, but going to the first slide is what are Postgres extensions. I think that in general, this group is very familiar with what they are. But there's 2 points that I really do want to hit on here with extensions. I think one of the things that I think excites me most about Postgres is that if you look back at Postgres as the Berkeley database project, researching how to create an object relational database, there's actually something that kind of came out of Postgres design, maybe accidentally on purpose. I do want to talk to some more of the original Berkeley researchers on it, but it's not that Postgres is necessarily an object relational database. It's that Postgres is an extensible database, that it was built from the get-go to be able to add functionality to it without necessarily having to fork the database. Now, certainly early on, you'd have to fork the database to add additional functionality, but really the beauty of what came in Postgres design was that it was possible to just keep adding functionality to Postgres without requiring to fork the database. And it did require making changes to Postgres to further enhance that, which we'll discuss a little bit. But that's a really powerful concept. And the second point I want to hone in on this slide is that there is this large landscape of both open source and commercial extensions. I think a lot of folks in this group are very familiar with the open source extensions that are out there, but there are entire businesses built on effectively commercial extensions on top of Postgres. And again, that's a really powerful notion. It's kind of like the Postgres economy in a way that we created something that's so special, is able to spawn all these different businesses, whether it's building things on top of Postgres or using Postgres as the heart of their business. And extensions really have a large role to play in that, which gets into the history of the extensions. The syntax for Postgres extensions has been around for over a decade now, since Postgres 9.1, but I know there's folks on this presentation today who are well familiar with building extensions prior to that existing. We are very grateful for the extension syntax because I would say as a recovering application developer, it made things a lot easier. Instead of having to futz around with the file system to figure out where to install everything, wink wink nudge nudge on the topic today, you had a very simple syntax where I could say all right, once this extension is installed, create extension, whatever it may be, PostGIS, because I have that on screen right now. And there you go, I have PostGIS installed. And again, that's really cool because anything we can do to make it simpler to install and use extensions, further drives their adoption, ultimately makes it even easier to develop and build applications with Postgres, and continues to drive that forward. Now, one thing I do want to level set is what can you build with Postgres? What extensions are available? And it really is a whole range of things. And for starters, there's extensions that I call the ones that you take for granted. If you're using any monitoring tool out there, you're likely running PG stat statements, and you may not even realize it. PGStat statements just helps to aggregate statistics across how queries are executing within your database, and then bubbles it up to whatever monitoring tool you use. I always like to say to users, you're probably using this without even realizing it. And it's definitely a great tool for performance tuning. Example I always like to give for my personal life was that back when, again, when I was, application developer trying to manage my own databases, I had some query that was actually, blocking my entire logical decoding system, that we weren't keeping up with transactions. I go into BGStat statements. I see like, oh, I have this recursive query where I should have had a select distinct on it, or sorry, a union with a select distinct instead of like this, gigantic query that was like amassing like, so many rows in it. Fixed it. I had 100x speed up in the query. Thank you, PGStat statements. Of course, side note, I got to say like, hey, I sped up this query by 100x, even though it was my fault that it was slow to begin with. There's utility functions to help with data types. UUID OSSP, again, very widely used. Maybe since newer versions of Postgres, there was the generand UUID function in there now, but anytime you need to generate UUID, you would create extension UUID OSSP. The other fun thing about this extension is that developers learned about SQL identifiers, where you have to use the double quotes in order to install this extension. I think I saw Keith on here today, PG Partman. And what's really cool about PG Partman too is that a lot of it is PLPG-SQL. And within that PLPG-SQL, you have a way to manage your partitions across all your tables, your entire database, etc. And again, that's really powerful because Postgres has added declarative partitioning, starting with Postgres 10, but PG Partman is still incredibly useful because there's all sorts of aspects you need around partition management that you just don't have in Postgres today. And this is, again, an example of Postgres being an extensible database, that it provides the core functionality, and you can use the extension to package together additional functionality that makes it easier for you to manage all of these things. Foreign data wrappers. Postgres has a whole interface to be able to interface with other databases. It could be other Postgres databases, it could be other relational databases, non-relational databases, file systems, etc. And here you go. You have a C-level interface that allows you to be able to design the calls that allow you to optimally use all these different databases. Again, packaged up in an extension, being able to add things as we go on. In terms of questions, I'll wait till the end to answer questions. This will be a relatively short presentation, so we should have some time for discussion. And last but not least, a little bit on this extension tour, as I saw Regina here, PostGIS. And I think this is one of the most powerful aspects of Postgres. Like PostGIS itself is incredibly powerful because you basically have a geospatial database that happens to be Postgres underneath. And Regina can confirm this. A lot of heavy PostGIS users don't even realize they're using Postgres. They think they're using PostGIS. And that is really the power of Postgres extensibility in a nutshell, is that it looks like you have like a brand new domain-specific database, and yet underneath it, it's just boring old Postgres doing all the things I expect a database to do. And that is also a very powerful notion. And then, just to add a coda to it, you have PG routing, which is an extension built on top of PostGIS, which is built on top of Postgres. So you sort of have a cascading effect of extensions building on top of Postgres. So we're supposed to talk about trusted language extensions today, and I've seen in this extension, on our path to the extension summit, we've talked a little bit, or we talked a lot about this topic, but really to set up trusted language extensions, it's important to understand the anatomy of an extension. And I think the folks who've built extensions before are familiar with this, but there's certain things that you need in order to have an extension. You need a control file. The control file is kind of like your packaging manifest. It tells you what's in the extension. That goes into a directory. You have SQL files. The SQL files effectively map out the objects that you're going to have in your database. So if you have functions that need to map to a C function, or if you need to create a table access method in order to build your new storage layer, that is the building block for that. And then if you have C-specific code that goes in a library file or a shared object file, that gets stored in a library directory. So very simple layout. And what's cool is if you go to create an extension, there's a particular pattern that it forms, because basically you need to know that when you have an extension, effectively, that's the information in the control file that gets then placed into the Postgres catalog. And then if there's any functions or objects or whatever you have in that extension, we need to do two things: that we need to install the object itself, but we need to make sure that there's a dependency on the extension. So that way, if we need to remove the extension or perform any upgrades, we know all the objects that we've collected. So why are we doing, why are we doing this? Sorry, this slide in twice. So why are we setting up this extension building 101? This really becomes, at the heart of why we build trusted language extensions. Because the first thing you've noticed is that we need to install extensions directly to the file system. Now, there's a lot of domains where that's restricted. Certainly managed service providers. I worked a lot with containers previously, and again, a container is effectively an immutable file system that once you have things installed on it, it's installed. And frankly, again, being a recovering app developer, you typically don't want to give your app developers access to your production systems because your app developers are going to install everything under the sun on them, myself included. But you certainly want to be able to restrict certain domains. But we also don't want to inhibit what our developers want to build. We want to make it as easy as possible for them to manage their code and be able to install and basically be able to install it in different environments. And that gets to another point, beyond just restricting the file system, is that some extensions may not be universally available depending on where you're running them. You might be running an extension on an on-premise environment that might not work in a managed service provider, or different managed service providers have different extensions available and installed. And then the final bit, and something that I've definitely personally experienced, is that what happens in Postgres between major versions is that the API or the ABI will change. So that's effectively the interface points you have at the C layer. And when that happens, that can break extensions. Ask any of the package managers, in terms of what they do to nag people to upgrade their extensions. They always want to make sure that they're keeping it up to date and ensuring that it's compatible. And this actually can also, but this can also lead to other things too, because me as the end user, this makes it challenging for me to perform major version upgrades, particularly if I'm dependent on an extension that hasn't updated itself to work with the latest version of Postgres. A subtle line of code change in Postgres could end up breaking an extension. Quick story that actually happened to me while I was managing PGTLE, where I think it was a change in Postgres 15.1 actually broke something in the PGTLE extension, so I had to fix that. But I think that's part of the point is if you're able to use a language that's on top of C, and you have the C layer abstracted away, in theory, it could make it easier to perform major version upgrades. So that leads into TLE. So I think there were two notions behind trusted language extensions, or TLEs, when they were initially designed. The first is giving power to the app developers to be able to build extensions. It's actually one thing I noticed as I started making the journey from app developer to quasi DBA to ultimately product manager, not writing code. And part of that journey was the power of putting some of my business logic in the database. There's always this tension between how much business logic do I want in my application code versus the database. But there's certain things for me that were just clear wins when it was in the database. The first being there's a lot of search functions that I was doing where if I could basically filter the data down to a very small set in the database and return to the application, I'd save on network time, processing time on the app side, et cetera. And there were some very clear wins there that by encapsulating them in functions, it was a win. But also solving things that were just much easier to solve in the database, having specific data types that solve a particular problem. Geospatial extensions, coming to mind. PG vector dealing with vector data and it being able to store and search over that in a database without having to first filter it out into an application certainly is a clear win. But the other thing was installing extensions. And I think this notion of portability is very powerful, that if I have a way to be able to manage my extensions from a SQL-based interface, it makes it much easier to move it between different systems. Now, we do need to be careful there as soon as we start saying SQL interface, because I don't want to suggest that, oh, we should basically have a SQL interface to ship C code everywhere, because we know that there's some challenges with C code. C is highly performant. You could effectively build anything under the sun using C, but it's not memory safe. And it's very easy if you're not familiar with what you're doing, and even if you're familiar with what you're doing, it's very, you can easily make some mistakes that could either lead to crashes or or possibly worse. So as we're thinking about all this with TLE, there's three things. First, we need an interface to be able to install and manage extension, effectively the extension code, regardless of environment. So a SQL interface to do that. We also need to make sure there's an appropriate trust boundary. Now, Postgres provides this with the notion of a trusted language, which I'll talk about in a second. But there's also some other things that we need to build with trust as well. For example, you might not want everyone in your environment to be able to install the trusted language extension. So we need to make sure there's appropriate access controls there. And then finally, what we need is, we need a way to ultimately package it up, which I think is what we're going to talk about a little bit on the Extension Summit. So here's where, if there's any takeaways with, why we built TLE, I think this is the slide that encapsulates it, is that by using Postgres built-in trusted language interface, it allows you to be able to write extension code in languages that we know are going to respect Postgres security boundary. So briefly, a trusted language in Postgres, actually, I'll step back a second. Postgres has this definition of a trusted language, which if you look at the definition of a trusted language, you have to effectively like dance around the documentation to find out what it is. But effectively, it is, I'd summarize as that, if you allow an unprivileged user to write code in a trusted language, they can't do anything to escalate their privileges, access the file system directly, or basically, do anything that would violate Postgres security boundary. So it's a pretty good definition. And arguably, the easiest way to violate that definition is that you, as the database administrator, mark an untrusted language as trusted, which you can do in the catalog. But I strongly advise to not do that. Now, we'll talk about what trusted languages are available. There's actually a great wiki page called the PL Matrix on the Postgres Wikipedia that shows the status of all the languages, or at least all the known PLs in Postgres, and if they're trusted or not. I suggest looking at that. But a big thing too around using a trusted language is performance. Now, there's a variety of trusted languages out there, and they all have like different properties around them. And the ones I have, the ones I'm showing today are the ones that are available in RDS Postgres. But the reason why I do want to show them is that part of the idea of trusted language extensions is allowing app developers who may be less familiar with C to be able to write extension code and access some of the same internals that a C extension writer would use, but from one of these languages. So here's some of the the known trusted languages today that work with TLE. If you're using the TLE open source project, you can use any trusted language that's available, or you can also use untrusted languages too, and just use it as use the TLE packaging mechanism to be able to write code in them. In part, then you lose the ability to you lose the trusted part of that, but you do have the extension installation aspect of that. So just real quick, there's a few things that we put in order to make sure that TLE can be installed safely. In part, it is an opt-in feature. So we do have a shared preload library for PGTLE called PG_TLE. And you do need to have your database administrator, your database super user install PGTLE initially. And again, that's to make sure that we're respecting your own security boundary there, that if you're going to use trusted language extensions, you do have an explicit opt-in to using it, at least today. After that, then you can have an app developer effectively create their own trusted language extension. So here's an example, a very simple function from when we actually announced TLE, which is two functions, a simple extension that allows you to install it. There's something called, you can basically give it a name like any Postgres extension. So this is called TLE test. You have, it looks like the SQL file in any extension that you would install. And it's effectively packaged up like an extension using that pgtle install extension command. If you go to the pgtle GitHub project, you can see the different interface points for that. And then once it's installed, you can then create extension like any other extension. It follows all the usual Postgres semantics. So effectively, for the extension installation on installation software lifecycle management, it's going to look just like it. Well, PTLE has its own interface for that, but then once once you've installed it, managing the Postgres extension is just like managing any other Postgres extension, and it follows those conventions. Effectively, what TLE is doing here is it's offering a I'll loosely say packaging mechanism because I think packaging has a lot more connotations to it, but it's a grouping mechanism for your code. And actually, one of the parts that I always found most useful in PGTLE was this part, being able to effectively version my stored procedures. When I talked about that example where I was putting certain business logic within the database I was managing, one part I would usually mess up on is what version of my stored procedures was running in a given database. And particularly if you have hundreds or thousands of databases that you're managing, that can be a challenge. Now, I had far fewer databases I was managing. It was more dealing with our developer environment, staging, and production. But I was managing the stored procedures within our migration scripts, which is totally fine, right? Because if I know what version of the migration that I ran, then I would know what version of the stored procedures are on that database. Kind of, sort of, maybe, unless someone like went in and manually modified it, in which case, shame on me for giving access to the database. But I didn't necessarily, there basically could be some gaps in knowing what version of a stored procedure was on a particular server. Now, with PGTLE, we can effectively, I won't say eliminate that problem, but significantly reduce the risk of that problem because here we go. We have a way to version our stored procedures and be able to know exactly what we're running at any given time and create a consistent, bear with me, packaging mechanism wherever we're running our code. And again, it goes beyond stored procedures because these are extensions. These examples are showing stored procedures, but there's far more that you can do to build. You can build with your code. So in terms of that, what else does TLE add? Because the first part we discussed was the packaging mechanism, but a lot of the power of Postgres extensions is being able to use the underlying Postgres internals that help build them. So one of these types of internals is called a hook. Hooks are the Postgres feature that you've never heard of, that are not really well documented, and yet they are the foundational part of many of the extensions that we build. And hooks can be effectively like any, I don't want to say like anywhere in Postgres, but they can be all over the board. And you particularly see a lot of them during the query execution process. For example, there's the process utility hook, which in that utility box allows you to modify any utility command coming in. So anything that's not a direct SQL statement. There's all sorts of hooks. There's password check hooks. There's client authentication hooks. There's hooks that get called around like shared memory allocation. There's hooks that get called at each step of the execution phase. And again, that's very powerful because particularly a lot of the extensions around adding different database semantic behavior to Postgres, these are coming from hooks. There's, I think, we could probably just do probably like a series of talks just on all the different ways you can extend Postgres. I mean, that's why David has organized the summit. But hooks are a very simply a powerful mechanism to define behavior in Postgres. Now, because they're very powerful, the hooks that we do expose in TLE, we do make sure that there is a super user opted to that. So remember, I can write this in a trusted language. Like an unprivileged user can define this behavior, but you do need someone with privilege to be able to enable something like a hook. For example, like a password check hook probably means that you have the ability to evaluate a plain text password that's coming through. Now, first, on that topic in itself, we can have a very long debate about that. Let's save that for Vancouver. That being said, because we do have this hooking, you do have the ability to be able to do these kind of password checks. You want to make sure that the user, when you enable a function that is basically as part of the password check hook, like there's a certain level of privilege to that function, or you want to make sure you do your appropriate evaluation to make sure that you trust that function. So there's that check. And the additional check, and this comes from that PGTLE admin role, is that you need someone who has administrative privileges over your TLE to be able to what we call register that hook. So there's a particular aspect of PGTLE called TLE features, which is effectively the way that you map hooks into the TLE. It's something that we've been building up since we launched TLE. So we've added a few hooks. There's both the check password hook and the client authentication hook. There's also the ability to register custom data types, which is pretty cool because data types are, you know, when I was an app developer, that's what attracted me to Postgres. It's like, oh, there's all these data types that I can do all these like rich comparisons against and index. Cool. Oh, wait, you can even add custom data types. That's even cooler. And what TLE allows is that it allows you to actually create the base data type. So you can really expand the type of data types that you're able to add in there. But this is what that TLE feature the TLE features portion of TLE does is that it enables that mapping, let's call it that safe mapping between trusted language code and the PostgreSC internals. So specifically with creating a hook, in order to create a hook, you need to match the hook function definition. So in the TLE documentation, we document on how to do that, so that way you can create it appropriately. But it doesn't need all the parameters that you would find in the hook function, otherwise it won't work. So in this check password hook, this is actually this is probably, I call this like the delayed check password test, meaning you're probably trying to avoid someone, trying to guess your password repeatedly, and if they keep failing, so what? Because they're not going to brute force it. Anyway, there are actually other, I'd say, more practical examples of check password hooks. But what's cool is that you can basically define everything around your hook behavior from within the hook function, and then it acts as if you wrote a C-based hook. You just happen to write it in a trusted language. So, like as mentioned, hooks do execute with elevated privileges, particularly, I'd say, particularly things around authentication. You want to be very careful. So there are some safeguards built into TLE to make sure that you're only enabling hooks when you want to enable hooks. So last but not least, choosing a trusted language. So this is, I don't know, I'm covered for this group. I think we're more focused on extension building, but I do want to talk a little bit about what an app developer goes through in terms of choosing a trusted language, because everything has its trade-offs that you need to be able to consider. And the golden rule, I actually took this from Jim Legensky, is when in doubt, use PLPG-SQL because it does have a lot of access to context that's already available in Postgres. And first and foremost, that's as the first example of PLPG-SQL. What's interesting about this, and I think this group is fairly aware of this, is that it is based on what we've seen today in PLSQL. PLPG-SQL was developed to try and make it simpler to migrate over from Oracle, but at the same time also gave a lot of rich functionality around Postgres. Even myself, being much more familiar with Ruby and then subsequently Python, and Python for a very long time, I could tell you like PLPG-SQL could be a little bit quirky if like you're not if you're not on the database all the time, but it is very well documented and it could basically solve all the problems that you need to in Postgres. And it already has like a lot of very simple ways to directly access your data from Postgres. So certainly an easy choice to go with. But wait, there's more, like PLV8, like writing JavaScript in your database. Like this is really cool. And I remember when this came out and like how mind-blowing it was. And in particular for JSON processing, PLV8 is awesome. The other cool thing is like PLV8 came out really around the same time as the document database. So you kind of had like this perfect storm of being able to process JSON and write it in JavaScript, both within your Postgres database, and it could be quite powerful. PLV8 also has another really cool feature where if you want to call another function or another PLV8 function from with PLV8, you can do a direct call and not have to go through Postgres function processing function processor, which adds a lot of additional overhead to it. Really cool. And now the one that is all a buzz right now, PL Rust, being able to write Rust code within Postgres. Well, and also execute Rust code within Postgres. But this is pretty cool, right? Because Rust is a compiled language. So you're saying there's a trusted way to run PL Rust within Postgres. And the answer is yes. There's a variety of, there's a few techniques to do that. First, there's some techniques you certainly want to be able to do on, wherever you're running Rust, on your server to make sure that you're guarding against breakouts. But additionally, there is there's a library, I believe it's what's called Postgres STD, which effectively compiles out some of the less trusted parts of Rust, such as unsafe function calls. But you can still get everything that you want in PL Rust today. You get, the Rust standard library, you get the ability to run crates, and again, you do want to evaluate crates to make sure that you ultimately are comfortable running them in your environment. But then you get you get this compiled language that is CPU efficient, memory efficient, and memory safe. Well, a lot of Rust is memory safe. And it's pretty cool. I wrote a blog post last year that was actually comparing some different function calls between PL-PGSQL, PL-V8, and PL Rust. I think first, I think I was doing some array processing, and you could see that the PL Rust calls were very comparable to the C calls. And then there's some additional vector processing, given I've been obsessing on vectors for like the past 14 months. And seeing Rust actually, really win against PL PGSQL and PL V8. I don't remember the numbers off the top of my head. I can look up that blog as soon as I switch windows. But pretty cool. And again, this brings us, in some ways, there's potentially the best of all worlds here because I can take an extension that normally I would write in C, particularly because I'm focused on performance. I can write in PL Rust, and then I can package it as a trusted language extension and run it anywhere that TLE is supported and PL Rust is supported. And again, that is very powerful because suddenly I have what I hope is the best of all worlds. I have this portability. I don't have to worry as much about major version upgrades because again, PGTLE is acting as that abstraction layer between the Postgres C code and my application code that I'm writing. So last slide, and then certainly looking forward to discussion. PGTLE is open source. And it's open source for a lot of reasons. A lot of it is because we want to make sure that trusted language extensions are as portable as possible. But in some ways, the ideas behind TLE are not original. Now, if you look at other databases, there is this notion of, let's call it inline extensions or inline SQL. You call them modules, you call them packages. But effectively, the idea is that I can take reusable chunks of code, package them together, and have them run, anywhere. It doesn't matter where the database is located or hosted. I think this is something that, I know I personally want to work with folks on figuring out how we can make this possible in Postgres. Because even in Postgres, this is not an original idea. Dimitri Fontaine was talking about this, I think, as far back as 2012, in terms of like his vision of where the extension framework was going. And I think what's great is, what I'm looking forward to about this extension summit, and hopefully I'm not in, conflicting meetings while it's going on, is talking about how we're able to make it simpler, really simpler for app developers to be able to, I'll boil it down. How can we allow app developers to leverage all the great parts of Postgres around function writing, function building, and ultimately packaging these functions and making it simpler for them to be able to move it wherever their applications are running. So it is open source, open to feedback, under active development. Continue to add more features to support Postgres, and ultimately we want to hear like what'll make it easier for extension writers to be able to use TLE both as a packaging mechanism and as a development mechanism. So with that, that is the end of my slides, and happy to get into a discussion about this.
Awesome. Thank you, Jonathan. There was one question about PL Rust in the comments. Stephen asked whether it compiles when you create the function. And so if there are compiler issues, they show up there.
Correct. So it compiles when you create the function, and that's where you'll get compile errors. I have definitely received my fair share of those. And there's a Discord. The folks, so PL Rust is developed principally by the folks responsible for the PGRX project, the folks at ZamboDB. And they were super helpful in debugging all of my really poor Rust code.
See, while people are thinking about the questions, I'll just jump in here. You mentioned using crates with PL Rust. How does that work with PGTLE, since like they have to be loaded from somewhere?
Yeah, that's a good question. I think this, I kind of call it shifting the problem, right? So TLE solves one problem in terms of now you don't need to necessarily have everything installed on your local file system outside of PGTLE itself. So if you're using PLRS and you need crates, you do need those crates available either within your file system or within whatever package management tools you're using.
Right.
So in some ways, it shifts the problem, but I think it's going to be a good discussion in terms of, okay, what can we do to help ensure that there is a trusted way of loading those?
Yeah, I wonder if they could be vendored and then just included in the upload through the function call.
Mhm.
Uh, and up Sharma asks if TLE is a requirement for any PostgreSQL extension, or is it dependent?
So it's not a requirement. This is a project that is making it possible to write Postgres extensions in trusted languages. So I mean, there's plenty of extension authors on this call who have written very, very, very good extensions in C that do not use TLE.
Well, and you can use trusted languages to write extensions without TLE as well. It's just a way of getting it in the
Yeah,
database without access to the file system, right?
yeah, correct. So PG Partman, I think I saw Keith here. PG Partman, a lot of it's PLPG SQL.
Right. Any other questions or comments or any implications that you're thinking about for extension distribution, extension packaging, extension development
Do we
for
just
TLEs?
unmute or do I have to hit raise hand?
Just,
Oh,
I mean,
that worked.
go for it.
Okay, yeah. So the crates thing kind of raised my interest. And I don't know if like Python has this ability to bring in libraries or if JavaScript has those, dependencies as well. But has there been any thought within PGTLE for kind of like first classing the idea of having like a local subdirectory or a local sort of file system layout for the native dependencies? I'm using native in quotes here because it could be JavaScript, it could be Python, whatever, of those languages so they could be installed in a way that's not operating system dependent. I know this is kind of a complex setup, but I guess what I'm getting at is that a lot of times you'll see someone say, you need to install this package, which is called this in Red Hat, or this on Mac, or this on, Debian, and then you can install my extension. Has there been any like push towards solving that problem by having your TLE extensions load things from like a sort of walled garden that you set up or something, right? So it's specific to the database instead of the OS.
Yeah, so that's a good question. I think there has been thought around this. I think this is going to be probably something that requires like a thorough discussion in Vancouver because what's interesting, if you look at the trusted languages that exist in Postgres today, one of the reasons, the definition of trusted language is that thou shalt not access the file system. But if you look at all these different languages, though, they all have external dependencies in some way, shape, or form. So through Perl, there's everything in CPAN. Through JavaScript, there's everything in NPM. But if you try to call these external, let's say you installed like the appropriate CPAN, libs and NPM libs, within your database. From everything I've tried, from everything I recall from playing with trusted, PLv8 and PL Perl, is that you still can't access those libraries. You can't make the include or the require call to get them. So I think where PLRS is unique is that first off, we just said like, oh yes, you can use your cargo crates here. But I think that also requires some more thinking in terms of like how we make that available. And like I'm not sure if that's OS specific, vendor specific, or if there's something universal that we can build that helps to make that more of a trusted piece. Because I think at the end of the day, we still want to give the administrator discretion in terms of what they ultimately install. With the trusted language extensions themselves, we're able to say like here, like we know here's the Postgres security boundary. We're operating within that security boundary. As soon as we start introducing additional dependencies, effectively, that becomes a judgment call. Like, are those dependencies going to operate within that security boundary or not? And we need to make sure that administrators still have the ability to make that choice. So I actually think this is a very good discussion topic. I think there's like some very good discussion topics around that, not just for something like PLRS, but just extension distribution in general. I think that is, I think that'd be one of the key discussions at the Extension Summit.
Has there been any thought to having the default version of an extension tied to the version of PostgreSQL instead of it just being 1.3 and whether I saw on Postgres 12 or 15, because 1.3 might not even work on version 12, but it would work on version 15. The versioning of the extensions, the versioning of PostgreSQL seem like they're almost too independent.
So David, I think what you need to do is chastise the extension developers to let them know like they should be versioning appropriately to to the version of Postgres that they're using. There is a good point in there though. There is a lot of freedom in terms of how folks can build extensions. So for example, just things I have top of mind. PG Vector. PG Vector has like it supports all the active versions of or all the support versions of Postgres. So, in terms of its versioning scheme, it could do, I know 070 is going to be coming out soon. So it's able to say like, hey, PG Vector 070, it works with these versions, done. PG Hinplan, meanwhile, maintains, I think, several back releases. So like I think 1.6.0 is the latest release. And that supports Postgres 16. I don't believe it supports the earlier versions. I have to double check, but there's something, there's effectively things of that nature. And then I know there's like all sorts of different things out there as well. Like PostGIS has its own life cycles to it. So there's something good in that. And maybe the answer is that becomes part of the control file, saying what version or like what versions of Postgres this extension is compatible with. So that way we're not necessarily doing something to break someone's environment. I'm just brainstorming on live TV.
That's kind of where this came from. I was looking at PGCon the other day. I actually just opened a bug report on this, but as a good topic. But basically, PostgreSQL and a dump restore will dump it without the version that's in the source database. And when you go to restore it, it's going to restore to whatever the current version according to the control file is, even if you're upgrading to a different database, versus restoring it to whatever the original version was. That dynamic just seemed like it was. I haven't thought this fully through, but that seemed problematic.
I think it's less problematic for trusted language extensions or extensions that have no C code in them, because PG dump does dump the extension, so you should be able to load it up. And I assume like base backup and the others do the same thing.
I haven't checked into that. I just know it dumps create extension, and then it'll dump any user tables that are marked as such by the extension. So these code tables are marked as being user tables for TLE.
What do you mean by code tables?
Yeah, that's a good point. Like, for example, my Tiger geocoder, it's all PLPGSQL, but it's only the create extension thing that's named. So if your table, your TLE table, it would try to reload it from the original source, wouldn't it? In which case it would be the wrong version.
So with TLE, so we had to add some things into TLE to make sure it worked appropriately with PG dump. So like I know for a fact that if you dump and load the extension, like it works fine. If it doesn't, then there's a bug and we need to fix it.
Okay. Yeah, I haven't played with this, and literally this is new to me for the most part, but I found the whole fact that the control file is not updated when you do alter extension to be supposedly, in my mind, it'll be buggy.
Yeah. So I know. So in the case of TLE, because it is, so it's in theory major version agnostic. Where I say it's in theory is because we need to make sure the TLE code and library itself are able to work with every major version. But then once that's abstracted away, the TLEs themselves can just be dumped and reloaded into into different versions of Postgres. I do think we have a tap test for that too. I have to double check, but that was major version upgrades was something we 100% tested for.
Well, I assume it'd be easier with PGTLE since there's no need to make sure the extension is installed on the file system of the new server.
Yep. If you look at the internals for PGTLE, effectively the TLEs themselves are in a table.
Right.
And then they
Yeah.
just call when you do a create extension, it gets loaded from that particular table.
Right. And when you do a PG dump, you ensure that that table is dumped to the dump file.
Yes.
Yeah.
But the key, and this is the thing that we had to solve for, so it does work, is that in terms of some of the loading in pgdump, I think a lot of the create extensions get called before the table, so we need to make sure that we created the appropriate dependency so that we load the TLE data before the create extension, or the create extension for the TLE itself.
That makes sense.
Yeah.
So you mentioned here in the comments you think that background worker support could be added. How would that work?
So it'd be similar to the other things that we've added, such as the data types and the hooks, which is effectively creating the interface between the C API and what we'd expose as part of the TLE API. It's actually similar to how some of things like PGRX and there's another one I'm thinking of. Well, I'll use PGRX because that came to mind work, where effectively it's binding to Postgres C API, but it's exposing it through a Rust API. So we do something similar with the TLE API.
No, that makes sense. I just thought the background workers were literally like an application that ran and started when the postmaster started up and was shut down when the postmaster was shut down.
But there's dynamic background workers, so
Okay.
yeah, and that's how a parallel query works.
Gotcha. Okay, got it. Sorry, my information's out of date.
No worries. Well, maybe one day we'll have some form of threading too, which will also help simplify that. Well, simple. I mean, I don't want to see like everything. I don't think like we'll get a wholesale replaced with threads, but I think there's certain areas where threads would help, and certain areas where background workers are the way to go.
Yeah, that makes sense.
Take.
So what other questions do you have about TLEs or extensions more broadly in packaging with relation to TLEs?
Just a random thought. Good.
No, you get it.
Just a random thought. Just have you thought about incorporating foreign servers and like pointing the TLE instead of a local database, and maybe pointed to like a master company-wide foreign table?
And
like a TLE registry?
Right, but yeah, something global would be nice. Like, okay, we host it on PGXN. There's a TLE registry, but just for a company who wants to kind of maintain code internally between projects, and they want a shared library, they can publish it on one server, set up a link to it over foreign server, and then just point at that.
Could be.
I mean, you could just use foreign tables for that, for the tables that TLE uses for its registry, right?
That's what I'm thinking. Yeah.
Yeah. That's a cute idea.
I think that just to go back since we have a few more minutes, I think I was asked to talk about the vision. And one way to view extensions is trying things out before they're in core, or before they're in Postgres. And the aspect that I would ultimately like to see in core someday is the ability to do that's called like the inline modules. There is a SQL standard syntax create module that is for this purpose. Some folks were trying to see if we could get that. I believe it was into Postgres 15. There's some pushback on the design. It died on the vine for the time being. But I do think it's something to consider, because when I talk to folks, whether it's random Postgres users, AWS customers, etc., go through TLE, One of the things that really stands out is, I think, one of the things that we had discussed here and I saw in the chat, which is this aspect, being able to version your stored procedures. And this is in part what modules aims to solve is, one, just having a SQL interface to be able to load all these things and group it together. But then once you have that grouping, you have the ability to version it. And this is the part that's very powerful. Like I see that, like as soon as I saw this, I was like, man, I could have used that. That would have saved me like hours of debugging code in production. Not saying that I was ever sloppy and installed random stored procedures in my production database, but I think that's kind of the vision, is that as much as Postgres is extensible. I led off with that. Like the fact that it is extensible has led to this just very widely adopted database. But I think there are things that we can also load in our extensions and bring back upstream. There's certainly reasons why to keep developing things in extensions. Like pgvector is actually an example of that, where we talked about it at PGCon last year. And part of the thought of not trying to add a vector data type immediately into Postgres was, well, in part first to make sure we could settle on what the binary format would be. And once that's solidified, then we could add it. But, I had an aside with Tom, and, we talked about the fact that this is something we need to move fast in. Like, this vector space is moving very quickly. Extensions are a way to be able to move quickly when something like Postgres moves more deliberately. So in part, this is, in some ways where TLE is our way for be able to see what kind of interface makes sense for being able to do, kind of inline extension loading, and ultimately, how we want to look that in how we want that to look in core.
Can you create data types with a binary representation in TLE?
Yes, as
That's
of
cool.
I want to say the 1.3 release. I have to double check the version. So the way that we're able to do it safely is that it actually leverages the byte A type. So when you create that representation, it stores it as a byte A. And what you get for free today is that if you create your equality and inequality operators, you can use a B tree lookup on these data types. So there's a ... there. If we wanted to be able to use like gist and gin and build data types for our other index interfaces, there's more work to be done, and that would require a TLE interface. I spent a lot of time playing with gist and gin, and the interface calls themselves involve pointers, so that will require some thought.
Yeah, I assume it's a similar issue like for Rust data types that are basically just Serday serialized.
Yeah, but we can at least like store things as byte A, and that's half the battle. And that allows us to do a safe representation on disk, as opposed to just, all right, here's some random binary. Good luck, don't crash the database.
Any other last minute questions?
Table access methods. Yes, table access methods are very hairy, as are index access methods. I spent a lot of time the past 14 months looking at the index access method interface, which has like a lot of brilliance in it, and certainly some more areas to develop. But like, it's amazing. Like the fact that we can implement effectively like vector indexes and get all the best parts of Postgres is a phenomenal advantage Postgres has.
One last question. Jonathan, are there any other topics that you think that you're just kind of, we're leading up to Vancouver, and we're going to be starting to think about just sort of what are some of the topics that we want to make sure to talk about when we do this roundtable? I think you mentioned one earlier, and I should have written it down and I didn't, but just any kind of final thoughts about topics that we should kind of make sure to discuss?
Just in general, or TLE specific?
Well, both. I mean, for sure TLE specific, but also just generally related to extensions.
I think my TLE specific one, I think, dovetails into the general one. So the first one is like, is ultimately a path forward to having some kind of inline extension management mechanism in core Postgres. So that's part one. I spent the past 5 minutes talking about that. But I think the big thing and why we're all here today is how do we make it easier for developers to install extensions, manage extensions, etc. You know, I think the notion of package management, and you know, in some ways, you know, thanks to the work of Andres, you know, finding the backdoor into XZ, like this also takes a new light too, because there's a huge security component to this. And I remember, David, like some of our earlier chats around this, you know, the first, you know, I think, you know, again, being app developer sympathetic, I definitely want to see ways to make it easier to be able to load extensions. Being, you know, having enough spent, you know, a lot of time on the other side, the first thing that comes to mind is, you know, security. Like, how do we create a protocol for managing the extension, you know, the extension ecosystem that also allows folks to opt into it and apply their own security or operational or, you know, whatever the requirements are on top of it. I think that's the thing. That's the thing that's most top of mind that I'd like to see. If not, I don't expect to have like a full resolution from the extension summit on it, but at least the start of it. Like, what is ultimately like that that universal packaging distribution protocol for Postgres extensions that we can all agree on.
Thank you so much.
Thank you.
Quick before we go, we got at the end of time here. I just wanted to key up that in 2 weeks, Yuri Reshkovsky is going to talk about his idea for universally buildable extensions, dev to prod, and that'll be on May 1st at noon Eastern and 4 p.m. UTC. Stop the recording. Thank you, everybody, for coming.